Hi, welcome to Nomi's Academy. In this video, we are going to learn how to find the derivative of a special function called the polynomial function. Let's take the question. Find the derivative of y equal to axn. This is a special function called a polynomial function where a is the coefficient and n is the power of the variable x. Alright, let's proceed. We're going to write the function again, and then, like any increment in x will definitely lead to an increment in y, mathematically written as y plus delta y equal to a into x plus delta x raised to the power of n. Alright, the next thing we need to do is to expand the bracket, or what we have in the bracket, and the power is n, so we are going to expand to the powers of n. So that will be possible using binomial expansion. So we are going to employ the idea of binomial expansion. Alright, let me quickly write it out using binomial expansion for x plus delta x raised to the power of 2. So when we are able to get the expansion for this bracket, then we can now bring it back to the equation and then continue the solution. Alright, the expansion for this, like the power of x decreases while the power of delta x increases. And you should also always note the coefficient for each terms. Alright, using the binomial expansion, the first thing we have, this is raised to the power of n. So the first thing we have is x raised to the power of n plus, in the first term, the power of delta x is 0, which is 1. And so that's why it does not appear in the first term. Then going to the second term, we have the coefficient, which is n, and then the power of x decreases to -1, and then we have delta x. Now the power of delta x is 1, while in this case the power of delta x is 0, and yet the power of delta x is 1. Now going to the next term, or to the third term, the coefficient for that term, or for the third term, is going to be n into n minus 1 all over 2 factorial. Now the power of x decreases by -2, and then delta s increases by 2. So we can just summarize the expansion by using epsilon, which shows that the expansion continues. But since we are working with the power of n, we can just summarize it and then write the last term, which is delta x, or plus delta x raised to the power of n. So we can have the expansion to be in this form. Alright, we are going to bring this into the equation. So that will be y plus delta y equal to a into x raised to the power of n plus nx raised to the power of minus n delta x plus n into n minus 1 all over 2 factorial x n minus 2 delta x squared, and then plus epsilon plus delta x raised to the power of 2. Then we close the brackets. Alright, the next thing we need to do, we can as well open up the bracket, and that will give us, and then we can also move plus y to the other side, or we subtract minus y from both sides. Doing that, we are going to get delta y equal to, we open up, a times this, we have ax raised to the power of n, plus a times this, we have an x n minus 1 delta x, plus a multiplied by the third term. We have an n minus 1 x n minus 2 delta x squared, all over 2 factorial. And 2 factorial is also 1 times 2, which is 2, plus minus or plus epsilon. Then we are multiplying a to the third term or to the fourth term or last term, and that will be a into delta x raised to the power of 2. Then we close, we don't need to close brackets. Remember, we are taking y to the other side, and that will be minus. And what is the value of y? The value of y is a x n. So we can write a x n. Okay, let me write the solution in this other line for simplicity. So we have minus axn. Now we have axn minus axn. So definitely this will cancel this. And then we are left with delta y equal to an xn minus 1 delta x plus an into n minus 1 x n minus 2 delta x squared, all over 2 factorial is 2, plus ellipsis plus a into delta s squared. Now we can divide through by delta x. Divide through by delta x. Divide through by delta x. Now to do that, we have delta y all over delta x equal to, now the first term, divide by delta x. An x n minus 1 delta x divide by delta x. The second term, which is an into n minus 1 x n minus 2 delta x squared, all over 2 divide by, we are dividing by delta x. Then the last term plus ellipsis, we have a into delta x raised to the power of n. Sorry, what we have here, let me make this clear. We don't need to write 2 here because the last term is meant to be delta x raised to the power of n. So here we have n. So a into delta x raised to the power of n. Alright, divide by delta x. Delta x cancel delta x. Delta x will cancel this. We are left with 1. So we have delta y all over delta x equal to an xn minus 1 plus an into n minus 1 xn minus 2 delta x divide by 2 plus ellipsis a delta x raised to the power of n over delta x. Alright, the next thing we need to do here is to take the limit of the function. the limit as delta x tends to 0. That will be delta limits as delta x tends to 0 for delta y delta x. So that will be limits as delta x tends to 0. For this we have a n x n minus 1 plus a n n minus 1 x n minus 2 delta x all over 2 plus ellipsis a into delta x raised to the power of n all over delta x. Okay? Now when we take the limit, delta y delta x becomes dy over dx equal to, now wherever you see delta x, you slot in 0. So we have a n x n minus 1 plus a n into n minus 1 x n minus 2 0 all over 2 plus ellipsis plus a 0 raised to the power of n all over 0. Of course, this will cancel out. From here, by the time this cancels this, we are left with just delta x. So that's why the whole of this will amount to 0. So we have delta y over delta x equal to 0 multiplied by all this is 0 and this is 0. So we are left with a n x n minus 1. So this is the final solution. So it means that whenever we have this type of function called a polynomial function, the derivative will always be a n x raised to the power of n minus 1. So when you have a function of this form, y equal to 4x raised to the power of 3. That is, the function given is in this form. So the derivative, using this idea, the derivative, the y over the x, will be, you can see that the coefficient is a, and then the power goes to multiply the coefficient, that is, the coefficient multiplied by the power, and then you have your x variable, n minus 1. So using that idea in this case, we have 4 times 3, x raised to the power of 3 minus 1. So following this idea, so the final result will be 12. 12x raised to the power of 2. So this will be the solution to the function given. Alright, we've come to the end of the proving. Thank you for watching. See you in the next video.